Hi, everyone. Today we're starting with Unit 8. We're on Lesson 1. We're going to be talking about angles and trig function values. Okay, so basically, definition of trigonometry is the measure of triangles. And there are two main approaches to trigonometry, right triangles and circles. We're going to kind of combine these together this year. So last year when you studied trigonometry, you studied degree and radian measure. Today we're going to review what radian measure is, how to convert between degree and radian measure, and how to set up basic trig function values. So our definition of a radian is the measure of a central angle that intercepts an arc equal in length to the radius of the circle. And basically our whole premise, our whole idea of radian measure is based on this fact, and I'm just not quite sure how many people really understand this. So if we look at this and we say the initial side of the angle is the x-axis. So the angle, okay, 1 radian, okay, is going to be, if we take this radius, the definition, if we take this radius, the length of the radius, and wrap it around our circle, the angle that's formed is what we call 1 radian. Okay, so how can we use this to help us describe the angles in terms of pi? Well, if we consider that 1 radian, if we open up, that angle would be 2 radians. Open it up again, wrap another radius. Now remember, these are the length of the radius of the circle. And then the little piece here that's left is a really small decimal. Okay. So how many degrees are there in a circle? 360 degrees. How many degrees are there if we go halfway around the circle? Okay. We all know when we open up halfway around the circle, it's 180 degrees. Now, last year you learned, oh, how many radians is it if we go halfway around the circle? And you guys all equated radians with pi. Okay. The reason we equate radians with pi is because mathematicians did a lot of work to work out the fact that this is really 3.14 radians. And because we use pi to represent 3.14, that became the number, right? We were using a math symbol to describe our angles instead of numbers all the time. And that's really where radian measure came from. So we can describe different forms of angles by using this concept that pi equals 180. 1 pi, 2 pi. Now, if we break our circle into 30-degree sections, this is a little hard to see, but we would have 30 is pi over 6. 60 is really 2 pi over 6, which gives us pi over 3. 90 is 3 pi over 6. So we can break our circle into equal portions. And when we divide our circle, our pi by 6, I should actually refer to that. When we divide pi into 6 sections, we get multiples of 30-degree angles, and we can describe in terms of pi. We could divide pi by 4. We could divide pi into 3 sections. And basically it extends and wraps all the way around, and there's a little pattern that happens. Now, you studied this unit circle last year. We're not going to make this a huge focus of this course, but you should have an understanding. And hopefully after we kind of talk about things over the course of a few days, you will. Okay, so the first thing we're going to talk about today is just simply how to convert back and forth. So if I give you an angle as a degree measure, you should be able to get that angle and understand what it means in terms of pi. The rule to convert from degree to radian is you're going to multiply that angle by pi over 180. So if I want to take a 60-degree angle and describe it in radian measure, I'm going to multiply by pi over 180 and then simplify, and I get pi over 3. Now we could also represent this as a decimal. That's the tricky part. We're not going to talk about it just yet. But pi over 3 is really 3.14 divided by 3. Negative 270. Now think about negative 270. We know in math when we open up an angle in the negative direction, oops, I don't want, right? We're really opening in the negative direction. We have to go counterclockwise, or actually clockwise. We usually open up counterclockwise. So negative 270 is equivalent to 90 degrees. Or so we could represent, now this is the tricky part, we could represent this angle two ways: as a multiple of 90. I shouldn't have gone into this quite so far, quite so deep just yet, but I did, which is pi over 2. Or we could represent it as the negative form of the angle, which I should have done for this example. And that's just going to be negative 270 times pi over 180. And now you're simplifying this fraction. And if you can't do the simplifying, in your head, just simplify 270 divided by 180 in your calculator. You're going to get a decimal. Change that back into a fraction, and then put the pi back along with it. And that would be the equivalent. So this really, I shouldn't have gone into this yet. This is the answer we're looking for because the original angle was described as a negative. Now here's a weird one, 107 degrees. Okay, so when I go and I multiply by pi over 180, I notice it's not going to go in evenly. Okay. When this happens, when the fraction is what we call not nice, we're going to use a decimal in our answer, which means we're going to use the number pi. For instance, here, I'm doing, clear this out. I'm going to take 107 divide by 180, and I get 0.59444. That's not going to, sorry, I have to plug the pi in. I knew that wasn't right. 100 times pi, hit enter. Now divide by 180. Hit enter one more time. So this is really 1.868 radians. So this piece here, pi over 180, we equated pi to 180. So we're not, that is just multiplying really by 1. But when our angles are not nice and we have to simplify, we're going to use the pi key in our calculator to help us. And that helps us get the radians in radian measure. To convert from radian measure to degree. Now here, we're going to be in radian measure. We're going to multiply by 180 over pi. So if I take pi over 6 and multiply by 180 over pi, here it's easy to see our pi's cancel. We really have 180 divided by 6, which is 30 degrees. I find it a little bit easier when I'm dealing with this situation, just replace pi with 180. The pi's cancel really anyway. So an example of that method would be -3 times 180 divided by 4. And now here's what I said. You want to kind of, if you do it using this method, you can kind of do these in your head, and then you'll get used to the multiples. 180 divided by 4 is really 45. So I have -3 times 45, and it's pretty easy to do this math in your head. This is negative 135 degrees. Once again, decimal. Now notice the difference. When we give you a pi, there's a mistake here. This should be 4.25 radians. Okay. When we give you a pi in the angle measure, you don't have to write the word radians. It's assumed it's radian measure. But if you just have a decimal, okay, then we're dealing with radians. We should really include the words. But most importantly, when you have a decimal, 4.25 radians, I'm multiplying by 180 over pi. Notice there's no pi there to start with. I just can't replace pi with 180. I have to physically do the math now. So this is 4.25. Let's see if I can get my calculator up. Oh, I always have a problem with that. So I have, what was the problem again? 4.25 times 180. And now I'm going to divide my answer by pi. So that would be 243.507 degrees. Let's take one moment here. If you're thinking about 4.25 in terms of the radian measure around the circle, so I have 1, 2, 3, think about 4. 4.25 is going to be somewhere around here. And that does look approximately to me to be an angle of 243 degrees. Another thing we're going to review real quickly today are setting up trigonometric function values. Now, from last year, you should have remembered, and geometry, the ratio, trigonometric function value is the ratio of the length of the sides of a right triangle. So if I have a right triangle here, when I'm describing trig function values, I'm referring to a specific angle. The angle across is the opposite. The angle coming from the touching the angle side is called the adjacent. And in a right triangle, this is our hypotenuse. And when we set up trig function values, we use SOHCAHTOA. That's our little saying to remember. In which case, the sine is opposite over hypotenuse. Cosine is the adjacent, the length over the hypotenuse, and tangent is opposite over adjacent. We should also kind of remember our reciprocal functions right now. The cosecant is 1 over sine or hypotenuse over opposite. Okay, so you can either flip your sine or you can just set up hypotenuse over opposite, whichever works for you. The secant is 1 over cosine or hypotenuse over adjacent. And the cotan is the reciprocal of the tangent function, and it's adjacent over opposite. So these are our reciprocal. And I know that this is a lot in one day, but it's all stuff you've seen before. When we set up function values for special angles in right triangles in previous courses, you should have learned the side lengths that we use. For a 30, 60, 90 triangle, the side length across from the 30 is 1. The hypotenuse is 2. And across from the 60 is rad 3. Okay. And this is a ratio you learn in your geometry class and you talk about again in your algebra 2 class. On a 45, 45, 90 triangle, our ratios are rad 2, and 2. Now, some teachers use 1, 1 and rad 2. And if you are more comfortable doing it that way, that's fine. But in this course, when I set up my ratios, I'm going to use that triangle. Okay. Also, I want to remind you that in previous courses, some of your teachers had you set up charts. That's all fine and good. But this year, my goal is to kind of have you learn how to set them up from triangles. Okay. Because in the future, you're not going to be writing down a whole chart that you memorized to evaluate one problem. Okay. So better be able to set up a function value when you have to. And that comes from memorizing your triangles. So in this case, we're going to set up our function values using our triangles. Okay. The sine of 30 is simply opposite over hypotenuse, 1/2. The sine of 45, opposite over hypotenuse. Now, it doesn't matter which one you use. You can use either angle here when you're doing your, putting your side lengths in. Now, tan of pi over 3. Okay, my brain thinks in angles. So instead of trying to kind of memorize a unit circle and figure out what pi over 3 is equivalent to, why not be able to quickly convert this? Well, tan of pi over 3 is the same as 180 divided by 3, which is the tan of 60 degrees. Okay. So the tangent of 60 degrees, we're going to go up to our 30, 60, 90, opposite over adjacent. Rad 3 over 1, which is simply rad 3. We don't have to write that denominator. Now, just like other topics that we covered in math, anything that applies to numbers applies to sine and cosine as a function. So we can evaluate trig functions. We can evaluate more complicated expressions. Just follow the order of operations and just do whatever the problem says. So here, we're going to be setting up the sine. Now remember, this is 180 divided by 3, so the sine of 60 times the cosine of 180 divided by 6. So this is the cosine of 30 degrees. This is the math you have to try to learn to do in your head. The sine of 60, well, sine opposite over hypotenuse. Sine of 60 is rad 3 over 2. The cosine of 30 is rad 3 over 2. And we're going to multiply these numbers together. So this is the math you have to remember. Rad 3 times rad 3 is simply just 3 over 4. Now I have the cosecant of 30. So now we're dealing with reciprocal functions. And again, here's the thing. You could kind of, cosecant is 1 over sine. So you could find the sine of 30 and flip it. Or you could do hypotenuse over adjacent because your triangle is right there in front of you. I know it sounds weird, but I usually find the sine of 30 first and flip it. So sine of 30 is 1/2, and when I flip it, I get 2. And then in our last example, cotan of 60, Cotan of 60 is going to be tan 60, right, and flip. So I'm going to find the tan of 60 and flip it. The tangent of 60 degrees, opposite over adjacent. So the tan of 60 is radical 3. We're going to flip it. We get 1 over rad 3. I have to rationalize this because I'm not allowed to have, with trigonometry, when we say exact function values, we're not allowed to leave the radical in the denominator. And I get rad 3 over 3. This one probably would have been easier, right? If we just had done in the original, I believe. Ooh, I did something wrong. Cotan 60. Tan 60. No, it should be rad 3 over 3. Hold on, give me one moment here. Tan is radical 3 over 1. So cotan is 1 over radical 3. Yeah, so our answer is rad 3 over 3. I have a mistake on my answer key. Sorry, guys. Sorry about that. And in our last little section of what we want to do today, again, remember it's reviewing. This is all topics you've learned before. When we find function values of what we call quadrant angles, we're going to kind of refer back to something called the unit circle. Our unit circle is a circle with radius 1 unit. Okay. And the whole premise of using the unit circle to find our function values is this. So if this, right, we go out 1 unit from the origin, we know clearly we have these points. We also know this is our 0. This is 90 degrees or pi over 2. These are our quadrant angles. They break up our quadrants. This is pi or 180. And this is 3 pi over 2 or 270. Again, these are quadrant angles. And the whole premise of being able to use these values is the fact that if we go anywhere in between and we have a point xy, we know that if we drop perpendicular line, this is x and this is y and this is 1. Well, if x squared plus y squared equals 1, we're going to kind of, if you see here, like the sine of theta is what? Sine of theta is y over 1, opposite over hypotenuse. So the sine of theta is the y value of a point on the unit circle. The cosine of theta equals x over 1. So the cosine is the x value of a unit circle. And then we also know that the tangent is sine over cosine. So our tangent can be found using the x and y values from the point. So when we can use to find our quadrant angles, you might find it convenient, right? Because the x value of our point at each quadrant angle corresponds to the cosine of that angle, and the y value corresponds to the sine. So for instance, the cosine of 180, if I wrap around and go to 180, remember, cosine, sine, the cosine of 180 is -1. The sine of 270, cosine, sine, the sine of 270 is also -1. The tangent of 90, well, when I go up to 90, right, my point is 0, 1. So when I go to do sine over cosine, I get 1 over 0, which is undefined. So the tangent of 90 is undefined. And hopefully you kind of remember that last year, some of our quotient, right, because it's a quotient of two functions, it's going to be undefined and not have answers in some places. And our cosecant of 180, so I'm going to go back to 180. That's the point I'm looking at. And the cosecant is 1 over sine. So I'm going to do it once again. 1 over the sine is 0. Also here, it's undefined. So you could use undefined, you could use not defined. I don't care what you write. However, you just have to understand that there are going to be some places where you're not going to be able to set up a function value, and it's okay. Okay. So we did review a lot today. Let's go back up to the beginning of the lesson. Okay. We talked about this concept of radian measure, kind of what it means to us in breaking apart the units or the circle, and how it correlates or corresponds to different angle measures, how we can convert back and forth between what we call degree measure and radian measure, both directions, and setting up some basic trig function values and using the unit circle to help us find quadrant angles. Okay, so the best way to make this work is for you guys to make sure you do the practice questions. Okay. Trig can be very difficult if you don't keep up with the work. Okay. Thank you all and see you soon.